Alright, so first I want to talk about the three types of friction. The first being static friction, and we know static friction is just a force that resists the initiation of movement, like a box on the ground, or a better example would be a Snorlax, because you just can't move them unless you have the fluid. Our second one is sliding friction. That's just the idea of two objects sliding across each other. We can see this with the micro welds acting against it, like this example here. I'm not sure what that is, but you can see the micro welds working against the blue object, forcing it to a stop. And our last one is rolling friction, and that's the idea where a ball or a tire rub against a surface, causing it to stick because of friction. And here's an example of a guy doing a wheelie, and he's not falling off his bike. The last thing I want to talk about for this section is net force. It's just the total force acting on an object. An example of this would be something with applying a force to an object 20 newtons to the left and 18 to the right gives us a total net force of 2 newtons. Now it's time to discuss Newton's laws, and I'll just let the videos do the talking for them. Now let's talk about Newton's first law. Newton's first law states that an object in motion will stay in motion unless acted upon by an outside force. In class we talk about that, and we relate it in terms of things floating, or the Earth, for example, which has a lot of inertia, which we call the law of inertia because it has a great mass. And I'll show you a real life example of that by using Dwight Schrute bobblehead doll. Alright? So if I push the Dwight Schrute bobblehead doll across the table, it comes to a stop because there's an outside force known as friction. In this case, sliding friction is acting against it, and that would be your outside force. So don't think too much into it and realize that this happens every single day. Here we have a golf ball at rest, the club and me being the outside force, and now it's no longer at rest. Alright guys, right now I'm going to show you Newton's second law. Alright, the idea that mass, force, and acceleration are all related. I'm going to be doing that by pushing a dog bed with a force, seeing how far it goes in terms of acceleration and distance. Then I'm going to add mass to it, and then push it with the same force, and we'll see how far it goes at that point based on how much acceleration it had. Let's do it. Alright, so here's the dog bed. We'll see how far it goes based on how much I push it. Not very accurate, but you'll get a general idea. I apply a pretty good force to it. It goes almost all the way to the end of the chest of drawers. Now let's add some mass to it. Alright, so now we're going to add some mass to it, and that mass is the Shiba Inu. Alright, put the Shiba Inu in the dog bed. Apply the same force to it. It only goes about to the beginning of the chest of drawers. So as you can see, more mass, less acceleration, less distance. Newton's second law. Alright, for our last one we're going to talk about Newton's third law. Newton's third law states that for every action there's an equal and opposite reaction. It also can be tied into the law of conservation of momentum. We talked about this in a transfer of momentum with the billiard balls, where the cue ball hits an 8 ball and the momentum is transferred and the cue ball stops. So we'll see an example right now using these two helmets. I'm going to apply a force to the lion's helmet. We're going to see an equal and opposite reaction. We're also going to see a transfer of momentum, or as I apply the force, the lion's helmet had momentum. It stayed in our screen. Hit the saint's helmet about 5 feet to the right, transferring its momentum to it. So in that example, we saw both the law of conservation momentum and also Newton's third law, where there's an action and a reaction force. Alright, the last thing I want to talk about for this chapter are the two equations you need to know. The first being the force equation, where force equals mass times acceleration. All you have to do is plug in what you know, solve for the unknown, and you'll be good to go. Just make sure you get your units right with the newtons, kilograms, or meters per second squared, whatever it is you're solving for. Our second formula is the weight formula, where weight equals mass times gravitational strength, otherwise known as force of gravity equals mass times gravitational strength. Pretty much the same aspect as the other one, where we have to solve for one, plug in what you know, solve for what you don't know. The key thing here is to remember that gravitational strength is always 9.8, but that's only on Earth, so we will be solving for gravitational strength
So keep in mind that it's not going to be 9.8 unless it mentions that we're here on Earth. Alright? Don't forget to study Section 3 definitions and know mass versus weight, and don't forget inertia. Talked about it very much. Good luck.